Hi, this is Mr. Zulu or Sir Lucas from Excellency Tuition Center. Are you writing GCE this year? This is the best place to be. We are located in Chawama at Fairfield Academy. Or if you are not in Chawama, you are somewhere else, you can still enroll for our online classes. And we'll be there to help you by the grace of God pass your exams. So today I'll be solving a question on calculus. Specifically, this is an examination question 2020 grade 12 paper 2, question 8b. And the question is, a curve has gradient x squared minus 4x plus 3. Find the equation of this curve if it passes through the point 3, -1. Now, all the times when you are told to find the equation of the curve where you have been given the gradient, you have to know that we are talking about integration. Why? Because gradient is simply the derivative of an equation or of the function. So at a point like this one, we have been given an expression for the gradient, and then they want us to find the equation. In other words, we want to reverse the process. We have differentiated, and then they want us to integrate and find the equation. So our equation is actually, okay, so solution. Our equation given is x squared minus 4x plus 3. This is simple. So how are we going to find the equation of the curve? So the first thing we have to do, when you are given the gradient, or sometimes in an exam they would call it the gradient function, you have to know that for you to get the equation of the curve, you have to integrate and find the value of the arbitrary constant. So here we are going to say the integral, okay, of, this is our gradient, x squared minus 4x plus 3 dx. This is what we're going to do. So we know that when you are integrating, all the times we use the formula. We have ax, n plus 1, okay, divided by n plus 1, then plus c. So now when you check, in this formula, we are adding 1 to the power, and then we are dividing by the same power. What we have here is what you divide with. This is integration. And then after you are done, you must add the constant c, because we haven't been given what we call the limits. So when we don't have the lower limit and the upper limit, the best you can do it is by finding what we call, or indicating what we call the arbitrary constant, because what we have at this point is actually an indefinite integral. We don't actually know the lower and the upper limit. So what are we going to do here? We are going to integrate. This applies only to this as well as this. So we'll start with this one. We have x to the power 2. So according to the formula, we are adding 1 to 2. Okay, so we are going to add the 1, we'll say plus 1. The same thing, again, we say we divide, then we have minus 4x. There is a power 1 here, we are adding 1, over. We are going to do the same thing again, 1 plus 1, then plus, we have 3. Now this 3 has a variable which is raised to the power 0 all the times. So here there is x, but that x is raised to the power 0. Why? Because we know in mathematics, all the times, anything raised to the power 0 is 1. So here it's the same as you have 3, because when you multiply 3 times 1, it will give you 3. So we are going to say plus c, 1 divided by 0 plus 1. Then don't forget plus c. Okay. So now, we are reversing. This is actually the derivative, and then we are trying to find the integral of what we have been given. So we are going to say this is equal to x 2 plus 1. We are going to have 3 over 3, okay? Then minus 4x to the power 2 over 2, then plus 3x plus c. So here you have x to the power 3, then divided by 3 minus 2 into 4, it's 2x squared plus 3x and then plus 3. Now, since we are looking for the equation of what we call the curve, therefore, we can rewrite this particular integral as y is equal to x to the power 3 over 3 minus 2x squared plus 3x and then plus c. Then from here, we are going to find the value of c. How are we going to find the value of c? We will use this particular coordinates which have been given. So this is our x, this is our y. So let me write them here. We have been given 3, -1. So at this point, this is actually our x, this is our y. Already, this is our equation. But we can't leave it like this because we don't know what c is. Okay? So now for us to know the exact value of this constant, we will need to replace where there's x, we put 3, where there's y, we put -1. Therefore, we'll say -1 is equal to, we have replaced. Then we'll say where there's x is 3 to the power 3 over 2 minus 2, then 3 to the power 2 plus 3, then 3 again plus c. We are looking for the value of c. Okay, let's go ahead and compute. We have -1 is equal to 3 to the power 3. Please, it's not 3 times 3, but we are multiplying 3 itself. Okay, we are multiplying 3 itself 3 times. So we are going to have 3 multiplied by 3 multiplied by 3. So 3 times 3, it will give us a 9. Then 9 times 3, it will give us a 27 there. So we are going to have 27 divided by 3 minus 2. Again, here we multiply 3 times 3. It will give us a 9. Then plus 9 and then plus c. Okay. So let's hope you are following. I think I can erase this part now. So that's how it goes there. You discover that it's very simple. So we are going to say -1 is equal to 3 can go into 27, of course. How many times? Automatically, it's actually 3 times. So, I mean 9 times. So we are going to have 9. Then we have minus 2 multiplied by 9, it will give us 18. Then we are going to have plus 9 plus c. Then -1 is equal to 9 minus 18, or rather we can say 9. Here we are going to subtract -18 plus 9. We are going to have -9 plus c. Then we have -1 is equal to 9 minus 9. It's a 0 plus c. -1 is equal to c. Okay? Therefore, c is equal to -1. Now, you don't end it here. Your answer was actually here. This is our answer. But the whole thing was done for us to know what value is c. Okay? So now we can rewrite. The equation of the curve is actually y is equal to, we copy everything here, x to the power 3 divided by 3 minus 2x squared plus 3x minus, in this case, minus 1. That is the value of c. So this is our equation of the curve. Hence, for you to check if your answer is correct, you can actually prove it. How? You can differentiate what you have here using the power rule. So when we differentiate, it should take us back to the original equation which we had at first. So